Hello, this is Algebra 2. We're in Chapter 8, Section 6. This is page 2 of the notes. It says solve a rational equation with one solution, and frankly, the part about one solution doesn't make a lot of sense. Here's what we're going to do. We're going to take our knowledge about how to add expressions and kind of use that to help us out. Look at our denominators. Denominators are always the problem. X, 3x. Boom, boom, boom. Our least common denominator, 3x. So we're going to multiply both sides by 3x, because when we do that, good things will happen. Mostly, we won't have any denominators anymore. That is a good thing. We have to be a little bit careful here. Look on the left. When the 3x multiplies into the 8 over x term, then the x's cancel, and you end up with just 24, because 3 times 8. The x's have canceled. When the 3x multiplies into the second term on the left, into the 11 over 3, in this case, the 3's cancel, and you just have the x times 11, or 11x. On the right, the 3x multiplies into negative 14 over x, and here the x's cancel. Also, you just have negative 42. 3 times negative 14. Boom. Now we're solving. We've got to solve for x. Do that by moving the 24 over. It becomes negative 66. You get divided by 11. X equals negative 6. Since the solution is x equals negative 6, check this in the original equation. And, go ahead. Check it if you want. I don't know why they decided not to actually leave space for checking this time. Oh well. Boom. Example 3. Solving a rational equation with two solutions. What is amusing about this is the fact that the book got its own example wrong. So, I need you to confirm that you have changed 3x plus 5 to 3x minus 5, and that means that everywhere else where it says 3x plus 5, a change has been made to 3x minus 5. Unfortunately, needs to happen. Okay, so moving forward, we're going to grab this, we're going to look for the least common denominator. Got x plus 3 and x plus 3 times x minus 4 as the denominators. The 2 is a nice whole number, don't worry about it. Least common denominator is, let me erase those circles, they get in the way, x plus 3 times x minus 4. It's the right kind of thing you need to multiply on both sides and not have denominators anymore. So that's what we're going to do. On the left side, we're going to multiply by x plus 3 times x minus 4. And we're going to do that on the right side as well. And I know the book's layout is suboptimal at this point, but it's like that. There. Now, when you multiply on the left, this is all one term because it's all multiplied together. So that multiplies, boom, and then the x plus 3's cancel. Boom, boom, goodbye. The x plus 3's have canceled. That leaves us with 3x minus 5, because remember we changed the problem, times x minus 4. On the right side, again, this is one term, and first it multiplies into the 2. It's actually really not exciting. There's nothing to cancel, so it's just 2 times x plus 3 times x minus 4. And then you do it again. Again, this one term multiplies into the 8 over x plus 3 times x minus 4. And when you do that, then the x plus 3's cancel, and the x minus 4's cancel. And then all you have left is that sad 8. But the 8's a winner. It'll take care of itself. So we'll go ahead and get rid of those crossing out lines. So it's plus 8. And now we just need to clean this up. And you might say, but it's factored. And the answer is, well, actually, no, it's not. Little pieces of it are factored in inconvenient ways. So let's expand it out. This is 3x squared minus 12x minus 5x. So it's really minus 17x plus 20. On the right, the stuff that's currently in green, that first business, is 2x squared. It was minus x times 2, so it's minus 2x minus 12. And then it's still plus 8. 8 still has no friends, but it's okay. It's cool with that. Move it all over to one side. It's quadratic. You want to move it all over, so you have just plain x squared. Once you subtract the 2x squared, you have minus 15x once you add the 2x's to make that work. And then over on the right, it was what? Minus 12 plus 8. So, that's really minus 4. And then you end up with plus 24. And now I realized that it wasn't actually that, because I made a mistake right back over here. That's not really 12. My sincere apologies here. It was negative 12, but I forgot to multiply it by the 2. So this is really minus 24. So then that's really like negative 16 when you add the 8. So negative 16, you have your 20. We're talking about plus 36. Okay. So once you've actually moved it over and you've perhaps checked your work in case you made a mistake like I did, you end up with x squared minus 15x plus 36 equals 0. This needs to be factored, some sort of thing with some x's. I need factor pairs of 36 that add to negative 15. And the answer is negative 3 and negative 12. So x equals 3 or x equals 12. It says again to check them, but again, they didn't actually devote any space towards checking it correctly. So, oops, oh well. Let's look at the checkpoint here. Okay. This is fairly complicated stuff. So nobody will call you any names if you just copy down the answers. At the same time, you're going to have to get around on this eventually anyway. The faster you try on your own, the faster you're going to master this. So I'll wait a few seconds for you to pause this. Give number 3 a shot. Just give it a try. We'll come back and check up with each other and see how we did. So this is what you get. You end up with x equals 2. The key thing here is that the least common denominator is actually 4x. You need the number 4 in order to take care of all of the number parts of the denominators, and you need the x in order to take care of the x's. When you do that, you end up with 11x minus 12 equals 10 after you've multiplied. That's probably the key spot right there. From there, you get x equals 2. I wrote check with a check mark. I did actually check both sides using a calculator. I really recommend you do that also, just to make sure that both sides are equal to each other. That's all you need to do, equal to each other. Again, I suggest you try getting started on number 4 on your own. Certainly it's a little bit tricky, but seeing where you're guessing right and seeing where you're guessing wrong can really help you long term with your learning. So try number 4 on your own, and then we'll come back and check on it. Okay, this one's harder than number 3 was. First of all, the least common denominator is x times x plus 2, because you have that x plus 2 as a denominator and you have an x as a denominator. You need to multiply that in to each of the terms on each side of the equation. I tried to color code that for you. Hopefully that makes some sense. In terms of the 1, you just multiply by x and x plus 2. There was no denominator to cancel. Boom, there you go. With the second term on the left, the 4 over x plus 2, the x plus 2's cancel, so you just have 4x. On the right of the equal sign, the 9 over x multiplies by x and x plus 2, so the x's cancel, and you just have 9 and x plus 2. You've got some stuff that looks like it's factored. You need to clean it all up, expand it, collect it. You end up with x squared minus 3x minus 18 equals 0. Factor it. X minus 6 times x plus 3 equals 0. Boom, boom. X equals 6. X equals negative 3. I checked them. Again, the goal of checking isn't drawing check marks. The goal of checking is to plug the number back into the original equation. You don't necessarily need to show it. You can do it on a calculator. In these cases, you need to do it twice, once for the left side of the equal sign, once for the right side of the equal sign. Both 6 and negative 3 worked out. So they're both solutions. That's all for page 2 of the notes. Thank you for watching.